Good morning. Today we are discussing the torque acting on a current carrying loop placed in a uniform magnetic field. Second part of the today's class. There is torque acting on a current carrying loop kept in a uniform magnetic field. Okay, consider a uniform magnetic field of magnetic field intensity B along this direction, and we are keeping a rectangular coil of length L, breadth B, P, Q, R, S, making an angle theta with the direction of magnetic field. Now, what is the torque acting on this rectangular coil because of the applied magnetic field? അതായത് ഒരു അപ്ലൈഡ് മാഗ്നറ്റിക് ഫീൽഡ് കൊണ്ട് ഈ ഒരു ഇതിലേക്ക് കറണ്ട് പാസ് ചെയ്യുന്നുണ്ട്. കറണ്ട് ഈസ് പാസിംഗ് ഇൻ ദി ക്ലോക്ക് വൈസ് ഡയറക്ഷൻ. Current I is passed through the rectangular coil. There are four sides: PQ, a current carrying conductor; QR is another current carrying conductor; RS is another current carrying conductor; SP also is a current carrying conductor. And according to Lorentz force, when a current carrying conductor is placed in a magnetic field, it experiences a force, Lorentz force, that is equal to BQV sin theta. Sorry, Lorentz force F is equal to BIL sin theta. Charge ആണെങ്കിൽ BQV sin theta ഉണ്ടാവും, force ആകുമ്പോൾ BIL sin theta. This is the Lorentz force. Therefore, here there is a Lorentz force, here there is a Lorentz force, here also, and on the both sides. And here we consider this as a rectangular loop. This is the magnetic field. It is kept like this with an angle theta. And here there is a force, here there is a force. Direction is perpendicular according to Fleming's left hand rule. This is towards upper side, this is downwards. And these two forces are equal and opposite. They cancel each other. അതുകൊണ്ട് ഈ മേലെ താഴെയുള്ള ഫോഴ്സസ് ക്യാൻസൽ ചെയ്യും. Then there are forces on these two sides. Here a force in this direction, here a force in this direction, but they are not acting along the same line. The line of action are different. Here along this direction, these two will not cancel each other. ഇത് രണ്ടും just opposite other cancel ചെയ്യും. ഇത് രണ്ടും cancel ചെയ്യില്ല. They are in equal opposite but in two different lines of action. Therefore, they constitute a couple. ഇവിടുന്ന് ഒരാൾ ഇങ്ങോട്ടേക്ക് പിടിച്ചു വലിക്കുന്നു, ഒരാൾ ഇങ്ങോട്ട് പിടിച്ചു വലിക്കുന്നു. അപ്പോൾ എന്താ റൊട്ടേറ്റ് ചെയ്യില്ലേ? Therefore, there is a rotating effect. That rotating effect is called torque. Therefore, the torque is because of these two sides, current carrying segments, these two sides. There can be, this is equal to force F1, this is equal to force F2. These two forces are BIL sin theta each, and theta is the angle between magnetic field intensity and I. Here the direction between current, direction of current and magnetic field is 0. Angle theta is 0 ആയതുകൊണ്ട് നമുക്ക് BIL എന്ന് എടുക്കാം. Force F is equal to BIL. Therefore, the opposite forces are BIL each. Therefore, torque is equal to, torque in the equation നിങ്ങൾക്ക് അറിയാം, torque to tau is equal to one of the forces into perpendicular distance. Perpendicular distance. What is perpendicular distance? We can consider this is the current carrying conductor of breadth B. This is the angle theta, and this is the perpendicular distance x. Therefore, cos theta is equal to adjacent side x divided by hypotenuse B. Therefore, x by B, or x is equal to B cos theta. The two forces can be represented just like this. This is F1, this is F2. This is the torque experienced is equal to force into perpendicular distance, force into x, that is equal to force BIL into xb cos theta, that is torque is equal to BIL B cos theta. Again we can simplify, length into breadth is equal to area, B into I into area into cos theta. Torque is equal to BIA cos theta. Now we can consider there are n number of turns. ഇതേപോലത്തെ rectangular loops n number ഉണ്ടെന്ന് വിചാരിക്കാം. There are n number of loops. Then torque to tau is equal to NBIA cos theta. This is the actual expression for torque acting on a current carrying loop with n number of turns. Okay, and we can consider two special cases. Case 1, as in the previous case, we can take case 1. If the plane of the loop is perpendicular to the direction of magnetic field. Magnetic field direction perpendicular ആയിട്ട് നിൽക്കുന്നെങ്കിൽ നമുക്ക് തന്നെ അസ്യൂം ചെയ്താൽ തന്നെ അറിയാം. ഈ പറഞ്ഞ എക്സാമ്പിൾ തന്നെ ഇപ്പോൾ മാഗ്നറ്റിക് ഫീൽഡ് ഡയറക്ഷൻ ഇത് അതിന് പെർപെൻഡിക്കുലർ ആയിട്ട് വെക്കുന്നത്. അപ്പോൾ വാട്ട് ഹാപ്പൻസ്, ഈ രണ്ട് ഫോഴ്സും ഗെറ്റിംഗ് ക്യാൻസൽഡ്, അതുപോലെ തന്നെ ഈ രണ്ട് ഫോഴ്സും ഗെറ്റിംഗ് ക്യാൻസൽഡ്. അപ്പോൾ ദർ ഇസ് നോ നെറ്റ് ഫോഴ്സ് അല്ലേ. ഇങ്ങനെ ആംഗിൾ ഉള്ളത് കൊണ്ടാണ് ഇത് രണ്ട് ഡിഫറെൻറ്റ് ഡയറക്ഷൻ ആവുന്നത്. ഇങ്ങനെ വെച്ച് കഴിഞ്ഞാൽ ഇത് രണ്ടും സെയിം ഡയറക്ഷനാണ്, അത് ക്യാൻസൽ ചെയ്യും, ഇത് രണ്ടും ക്യാൻസൽ ചെയ്യും. ദെർഫോർ ദർ ഇസ് നോ നെറ്റ് ഫോഴ്സ്. ദെർഫോർ when the plane of the coil is kept perpendicular to the direction of magnetic field, then theta is equal to 90 degree. Torque tau is equal to NBIA cos 90. NBIA cos 90. What is cos 90? Cos 90 is equal to 0. Therefore, this is equal to 0. Second case, case 2, when theta is equal to 0, when the plane of the coil is kept parallel to the direction of magnetic field. This is direction of magnetic field. This is the plane. Then theta is equal to 90 degree. Theta is equal to 0. Parallel. Theta is equal to 0. It is kept in the direction. This is the direction of magnetic field. The coil also is kept parallel to the direction of magnetic field. Theta is equal to 0. Then torque tau is equal to NBIA into cos 0. Cos 0 is equal to 1. That is equal to NBIA. This is maximum. Therefore, when the coil is kept parallel to the direction of magnetic field, torque is maximum. When the coil is kept perpendicular to the direction of magnetic field, torque is 0. And actual torque, when there is an angle theta, torque is in between these two values. In മറ്റ് ആംഗിൾസിനൊക്കെ നമുക്ക് ഇതിൻ്റെ ഇടയിലുള്ള വാല്യൂസ് ഉണ്ടാവുക, ഫ്രാക്ഷൻസ് ഉണ്ടാവുക, കോസ് തീറ്റയുടെ വാല്യൂ. therefore in between. Therefore maximum torque is acting when the plane of the coil is kept parallel to the direction of magnetic field, and torque is minimum when the coil is kept perpendicular to the direction of magnetic field. That's all for today. Thank you.